Hi everyone, we are from A4 CDCS 110 from Group 3F. So this is our team members. My name Muhammad NAZIRUL bin FAZRUL and working together with DANIAL, Muhammad ALIF and ZOLFAHMIZAL. So what is differentiation? Differentiation is a method of finding the derivative or rate of change of a function. The second one is process to find the rate of change of velocity with respect to time in a function. And the third one is the rate of change function is defined as dy over dx equals to x. So the application for this topic is first one is related rates, and we also have maxima and minima, and then inflection point, concave up and concave down, and
Okay, for the problem statement, given fx equal to x minus 2 power of 4 minus 1. Find the a, the x-intercept and the y-intercept. B, the interval where fx is increasing or decreasing. Hence, determine the extreme of C, the interval where fx is concave up or concave down. Hence, determine the inflection point if any. Sketch the graph of fx by using the above information.
so we go to the first question. The question is given fs equal to in bracket x minus 2 power of 4 minus 1. So find a the x-intercept and y-intercept. So the first one we go to the x-intercept. So when x-intercept does y equal to 0, then we write 0 equal to in bracket x minus 2 power of 4 minus 1, and negative 1 we move to the left, so we get 1 equal to in bracket x minus 2 power of 4. Then we calculate and we will get x equal to 3. So the coordinate for x-intercept is 3, 0. So next we go to the y-intercept, thus x equal to 0. So fs equal to in bracket 0 minus 2 power of 4 minus 1. So we get fs equal to in bracket negative 2 power of 4 minus 1, and we get fs equal to 15. So the coordinate for y-intercept is 0, 15. So for question B, the interval where fx is increasing or decreasing, hence determine the extreme point if any. So for this question, we just need to use the equation that has been given, which is fx equals to x minus 2 power of 4 minus 1, and then we need to find the f prime x, which is we need to extend the equation that has been given, and we will get x power of 4 minus 16 x power of 3 plus 72x square minus 64x and plus 15. And then from the equation we just need to differentiate it, and we will get 4x cubed minus 48x square and plus 144x minus 64. And you need to know that f prime x is equal to 0, and then just use the calculator and you will get x equals to 0.5359 and x equals to 7.4641. And then you need to draw a line. This is for you to find the increasing interval and decreasing interval. And the increasing interval we get 0, 7 and 7 infinity. For decreasing interval we get the negative infinity to 0. And below that we are find the extreme point. For this question we just use the equation that have been given and substitute the value with 0 and 7. So we will get the answer for extreme point.
So for question C, the interval where fx is concave up or concave down, hence determine the inflection point if any. So first we need to use the equation from question B, which is 4x cube minus 40x squared plus 144x minus 64. We need to differentiate the equation, which will give us the 12x squared minus 96x plus 144. Then we just need to substitute the new equation with 0 and 7, which will give us 144 and 60. Since f prime x equals to 0, so we can factorize it because 12x squared minus 96x plus 144 equals to 0, which we can factorize, and we will get 6 and 2. After that, we need to make the test table to test the value we, to show that it is valid or not. So when we do the table, we get concave up and the concave down value. So for in the inflection point, we just need to substitute the the equation from the first question with 2 and 6, which will give us -1 and 255.
For the conclusion, differentiation is a branch of calculus that deals with the rate of change of a function. The derivative of a function is a measure of how much the function changes as its input changes. For example, the derivative of the function f(x) equal to x2 is 2x, which means that the function f(x) is increasing at a rate of 2x for every unit increasing in x. The derivative of a function can be used to analyze the relationship between two or more quantities that are changing. For example, if we have a function that represents the distance between two objects as a function of time, we can use of the derivative of the function to find the rate of which the distance between the objects is changing. This information can be used to predict when the objects will collide or to optimize the trajectory